Now, sometimes you may get the information in this format. Suppose there is information regarding this. You have information regarding x bar, y bar, okay, summation yi square. So information will be given in this format. You don't need to find out, summation xi minus x bar whole square from the observations. Rather, you have information on all these things. Now, if you have information on all these things, using the formula summation xi square minus n x bar square, you will be able to find out summation xi minus x bar whole square. Similarly, summation yi square minus n y bar square. If you do this thing, you will get information on summation yi minus y bar whole square. And then you will proceed in the similar fashion. So sometimes you will get observation on xi and yi. And from that observation, you need to calculate mean, then all the whole squares, etc. And sometimes you will get the total of summation xi square, summation yi square, summation xi yi. You will get information on x bar, y bar. Then put these things in the similar formula, and you will be able to find out alpha hat, beta hat, and rest of the information which are required for that particular problem. Okay. So I hope if the information comes in this way, you will not face any problem. Are you getting the thing, or you need to derive alpha hat, beta hat, etc. using this kind of information setup, or you will be able to do it on your own?
Ma'am, so that expression summation xi squared minus n x bar squared, that is just simplifying that square expression, right, in the denominator, summation xi minus x bar squared. So, ma'am, it's simple. I think we'll be able to do that.
You will be able to do that. Yes, you should. You should be able to do that, However, I'm asking, However, I'm asking if you feel a particular numerical exercise based on this kind of information, that it will be better if we solve it in the class. In that case, I can find out a numerical exercise based on this kind of information. That I am asking whether we need to discuss it, or you will be able to do it. That is my question.
Okay, ma'am, I think we should discuss at least one numerical exercise.
For rest of the students, Oishi, what is your feeling? You will be able to do it. If the
Ma'am, I'm trying to do it. If there's any doubt, I'll tell you.
Okay, শরীর খারাপ?
না না, একটু ওই ঠান্ডা লেগেছিল, এখনো ঠিক যায়নি।
আচ্ছা আচ্ছা, ঠিক আছে। অমিত?
হ্যাঁ ম্যাম।
অঙ্কগুলো কি করেছো?
হ্যাঁ ম্যাম, চেষ্টা করেছি, আর একটু সময় লাগবে, আর একটু সময় পেলে।
আচ্ছা।
কি?
So so I am trying to find out one numerical exercise, based on this kind of information. Just give me a minute or so. So please write down a numerical exercise, a problem. A sample of 20 observations. Consider a sample of 20 observations corresponding to a regression. Yi is equal to alpha plus beta xi plus ui. Okay, where ui is normal with mean 0 and a constant variance sigma square. So you don't need to write it, So usual information or usual assumptions we are considering, expectation of ui is equal to 0 and variance of ui is equal to sigma square, a constant. Okay. Then the information, a sample of 20 observations corresponding to the regression model. Given this regression, gave the following data. Summation y is equal to 21.9. Summation x
সামেশন ওয়াইটা একবার রিপিট করবেন?
is it not visible?
ও সরি আমি বোর্ডই দেখিনি। ঠিক আছে,
ঠিক আছে। Summation y means yi, ঠিক আছে, y minus y bar whole square. This is equal to 86.9. Summation this is equal to 106.4. 106.4. Next, summation x. This is the thing. The question is estimate alpha and beta. Calculate variances of both the estimators. And comment on goodness of fit of the model.
ম্যাম এই কি বার করতে হবে একবার রিপিট করবেন?
Estimate alpha and beta number 1. Number 2, derive the variances of the estimators. Derive the variances and you can add covariance of the estimators. So you can do all these things. You have to put these things in the formula. Third, comment on the goodness of fit of the model. Comment on goodness of fit of the model. Okay, so suppose these 3 questions are there. Okay, I'm not adding any question on hypothesis testing at this moment. So first you have to find out alpha hat, beta hat. So we will start with beta hat. And formula for beta hat, what is that?
Summation xi minus x bar into yi minus y bar by summation xi minus x bar whole square.
So all the information are already there. You have to put the information and calculate it. So it is 106.4 divided by 215.4.
And 0.49
.494.
Yes. Now what is the formula for alpha? Alpha hat?
Y bar minus beta hat x bar.
y bar minus beta hat x bar. So put the matters. You have y bar, x bar with you, beta hat, calculate it. Find out the result.
Minus of 3.46.
Minus of 0.46. So the first part is done. Derive alpha hat, beta hat. Next, you have to find out variance of beta hat and variance of alpha hat. And if possible, covariance of alpha hat and beta hat. So first, variance of beta hat. What is the formula?
Sigma u squared by summation over i's xi minus x bar squared.
Okay. Now we have no information on sigma squared. So what we will do?
We'll use the unbiased estimator for sigma u squared, RSS by n minus 2.
RSS by n minus 2. So variance of beta hat, actually we are finding the estimated value. So it is SU squared divided by summation this thing. So first we need to calculate SU square. Okay, then only we will be able to calculate variance, estimated value of variance of beta hat. Okay, so we need to calculate SU square. Now what is the formula for RSS?
TSS minus ESS.
TSS minus ESS. Now Lakshmi, what is the formula for TSS?
The summation yi minus y bar whole square. No?
Very good. So let's first write down TSS. And the value is 86.9. Now ESS we need to find out. So what is the formula for ESS?
And beta hat square into summation xi minus x bar whole square.
Beta hat square is there any alternative formula?
Summation over i's yi hat minus y bar squared.
Now I didn't get the formula. Aratrik, please repeat it once again.
Summation over i's yi hat minus y bar squared.
That is not the definition which we will use when we have
Beta hat into summation xi minus x bar into yi minus y bar.
very good. That information, either we can use the formula beta hat squared summation x minus x bar whole square, or we can use the formula beta hat into summation xi minus x bar into yi minus y bar. So you can use any of the two formula. So if we use any of the two formula, what is the value of ESS? Please find out the value of ESS. Beta hat is already with you and you have information on summation x minus x bar whole square, or you can use the alternative formula. If somebody uses the alternative formula, then also no problem. I'm writing the alternative formula.
ESS is 51.72.
Just what is the value?
51.72. ESS.
I'm just not getting it. আর একবার
52.136.
52
approximately 52.
Ma'am, 52.45.
45.
52.4.
Okay, 52.45.
152.136 আসছে।
I think so. That will be the answer. একটু ডেসিমাল প্লেসে দুটো নিলে ভ্যালু নিলে একটু চেঞ্জ হতে পারে slightly. So we will get the value for RSS. So tell me what will be the value of RSS? 34 point something. It will be
and 34.764.
34.764. 34.76.
ম্যাম
Yes.
ম্যাম বলছি এখানে আপনি দুটো ফর্মুলা লিখেছেন তো আমি বিটা স্কোয়ার ইনটু সামেশন xi মাইনাস x বার স্কোয়ার দিয়ে করলে 51 পয়েন্ট সামথিং আসছে আর সেকেন্ড ফর্মুলাটা দিয়ে করলে তখন 52.136
হ্যাঁ সেটাই বলছি বিকজ এগুলো তো সব ডেসিমালে আছে একটা অ্যাডজাস্টমেন্ট হয়ে যায় বাট হাউএভার ইউ আর গেটিং আ ভেরি ক্লোজ ভ্যালু 52 তাই তোমার মেজর কিছু প্রবলেম হবে না এটা হবে মানে বিকজ অ্যাকচুয়ালি when there is a decimal place ওই প্রবলেম গুলো হতে থাকে ওকে আচ্ছা তাহলে তোমার এসইউ স্কয়ারটা এবার ডিরাইভ করে ফেলো what is the value of SU square then? Your n was 20, I think.
And 1.931.
1.93. So
and
next,
ma'am, the variance is 0.00897.
Okay. So coming to the variance part. Denominator is too large. So একবার বলবি 0.00 Okay. And in the similar way, once you have information on SU square, find out variance of alpha hat and also find out covariance. Derive these two things. Check the formula and do these things.
Ma'am, estimated variance of alpha hat is 0.873.
0.873. Rest of the students, দেখো এটাই হচ্ছে কিনা. If you get something else, please tell me.
Miss, the covariance is minus 0.08.
is 0.08. বাকিরা সবাই এটা পাচ্ছ তো? কোভেরিয়েন্সের ফর্মুলাটা সোজা মাইনাস এক্স বার স্কোয়ার ডিভাইডেড বাই সামেশন এক্স আই মাইনাস এক্স বার হোল স্কোয়ার। আর ভেরিয়েন্স অফ আলফা হ্যাটে ভেরিয়েন্স অফ বিটা হ্যাট আছে, তার সাথে আর একটা অ্যাডিশনাল কম্পোনেন্ট থাকছে। সবাই তাহলে এই আনসার গুলো পেয়েছো?
ম্যাম বলছি ডেসিমালের চেঞ্জ হলে তো মানে বেশি চেঞ্জ হলে তো অসুবিধা হবে, কম মোটামুটি একটা মিনিমাম ডিসটেন্স থাকলে তাহলে তো প্রবলেম নেই।
বেশি চেঞ্জ। আর তোমার যদি
আচ্ছা
ইনফরমেশন ডেসিমালে না থাকে তাহলে তো আর কোনো ঝামেলাই থাকবে না। For this particular problem, the information is there with the decimal place, and for that matter, you are getting this kind of changes. However, if it is with the whole number, in that case, there will be no problem at all.
ওকে ম্যাম।
Okay, so in this way, we can proceed. Now, if typically we have a particular hypothesis, so we have to test that hypothesis. If it is required that you need to set an interval, in that case, you have to do this, for setting interval of alpha hat and beta hat, we will use t statistic. While for setting the interval for sigma square, we need to use chi-square. So all these things are there. So this is another way where we can have information in this way, and then we have to proceed, and find out the results. Now I'm going to, several other questions. One is given by your class. Question number 8 in Madala. Question number 8 in Madala. So all of you has the book with you, so you can check it. So I'll discuss 8 at this moment. I think 8, 9, and 10. Let me check what is question number 9. No, mostly 10. 10 is 10 and 11. Question number 8, 10, and 11. These 3 questions. Now, question number 8 is telling, given data on y and x, explain what functional form you will use and how you will estimate the parameters. Okay. So, a statement is there, and from the statement, we have to understand what will be the functional form. And once we understand if the functional form, using that functional form, how I'll present the regression equation so that I can estimate the parameters of the model. So empirically, how we will present that function, that kind of question. So first is, y is a proportion and lies between 0 and 1. Y is a proportion and lies between 0 and 1. So my starting point is, anyone else in the class, could do it? In that case, you can share your thoughts as well. Anyone? Ritam, Pratush, acha tomra? Roll number 1.
পারিনি করতে।
আচ্ছা। দর্পক, অভিষেক, ট্রাই করেছো? সম্ভব?
হ্যাঁ ম্যাম ট্রাই করেছিলাম কিন্তু পারিনি।
হয়নি।
তিনটেই হয়নি না খালি প্রথমটা হয়নি? আচ্ছা ঠিক আছে, প্রথম একটা একটা করে। So this is the information. Y is lying between 0 and 1. Okay. Now, when we will define the functional form, we have to remember ultimately we have to reach to a regression equation. Okay. So we can, present it in any way. If I write a by 1 plus a, that is also a fraction lying between 0 and 1. Okay. A divided by 1 plus a. Okay. So if this is the format, that always it is a proportion lying between 0 and 1. However, a will not work. I have to write something which will work, which will ultimately result in a regression format. Okay. So I'm defining y as e to the power alpha plus beta x divided by 1 plus e to the power alpha plus beta x. Okay. So any a by 1 plus a will satisfy this condition. However, I have to write a specific a so that I can bring the aspects, of a regression model. So this particular format is basically format of a logistic distribution. Normal distribution, so logistic distribution. This is logistic.
কোনটা ম্যাম y is equal to ওইটা সেটা
E to the power alpha plus beta x divided by 1 plus e to the power alpha plus beta x.
Ma'am, how will we know that we have to use e to the power alpha plus beta x dot 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 these kind of things in this particular question?
Okay.
Means কি দেখে আমরা বুঝবো এই জিনিসটা যে হ্যাঁ এইটা এখানে ইউজ করব?
রেশিওটাতে তুমি বুঝে তোমাকে a by 1 plus a ফরম্যাট আনতে হবে। So in that case it will lie in between 0 and 1. এটা বুঝতে পারলে তো?
হ্যাঁ।
ঠিক আছে। এবার তোমার তো রিগ্রেশনের ফরম্যাটে নিয়ে যেতে হবে এটাকে। এবার তুমি যদি এর বদলে আলফা প্লাস বিটা এক্স ডিভাইডেড বাই 1 প্লাস আলফা প্লাস বিটা এক্স লেখো, রিগ্রেশনের ফরম্যাটে ওটাকে নিয়ে যেতে পারবে না। আলটিমেটলি তো তোমাকে লেফটে একটা ওয়াই এর ফরম্যাট আর রাইটে একটা ফরম্যাট থাকবে which will indicate a constant plus a coefficient multiplied with a variable plus error. In this structure you need to put the matter. তাই তো, মানে because they are asking this is the information and what functional form we will use so that we can empirically estimate the function. We can empirically estimate y. This is the idea. Okay. So we know about several functional forms. At this moment, you are not familiar with the logistic distribution. Okay, it is a continuous distribution. In your class, in your last statistics syllabus, you didn't have the logistic distribution. However, it is a very commonly used distribution. Okay, especially in context of regression framework, e to the power kind of expression that is very, very common or familiar. When from a function, we will like to move towards regression framework, many a times we consider the exponential format, because if we consider the logarithmic transformation, in that case it will be alpha plus beta x into log e. Okay, so from your experience you need to understand all these things. So I think you have no information about the logistic distribution. However, it is a very commonly used distribution in context of statistics, econometrics, etc. Okay. So logistic distribution is a half normal kind of distribution with a longer tail. This kind of thing, half normal kind of distribution with a longer tail, or we present it in this format too. So this kind of distribution. So this is the format. Now, looking at this, we are not understanding whether it will move towards regression or not. Okay. So next, what I have to do, I have to consider a Z. Achha. Once you understand, my starting point is a logistic distribution. In the next step, what will come in your mind that you will have only e to the power alpha plus beta x. You have to adjust the expression in such a way so that you get only e to the power alpha plus beta x. So once you get e to the power alpha plus beta x, if you consider the logarithmic transformation, you will get the format of a regression, alpha plus beta x, okay, the linear format, the format you know. So what I am doing, I am considering z, which is equal to 1 minus y. So tell me, what is 1 minus y? Find out and tell me what is the value of 1 minus y. Anyone?
From 1 by 1 plus e to the power of alpha plus beta x.
So are you getting this?
Yes, ma'am.
Yes, miss.
So you have one y and you have one z. So from using y and z, how we get simply e to the power alpha plus beta x?
Y by z.
Y by z. Everybody? Can we go for y by z?
Yes, ma'am.
Okay, so in that case, what notation I'll use? Then I'll consider are we getting all these things? Then I'm calling this, log. This is called the if you take log in one side, that will be the semi-log transformation. This is the log-log transformation, okay, double log transformation. You are transforming both y and x, both the left-hand side and the right-hand side. So this I am calling y prime. Then we randomize the model. Considering is the additive spelling right?
Yes, ma'am.
Okay. So finally, if I like to put the entire thing in the format of a regression, this will be the format. So this question is based on model specification, So in the beginning, when I started to talk about the regression, etc., some issues I discussed, regarding the specification of the model. How we will specify. So from economics, we are getting some idea about the functional relationship between the variables, So if this is the functional relationship between the variables, how finally, empirically, I'll estimate the parameters or I'll estimate the function. Okay. So this concept is very important. Model specification. What will be my model specification? To estimate a particular function empirically. So these three questions are based on that kind of idea. Specify a model. This is the concept. This is the functional format I'm telling you. And what will be the model specification, which will be, which you will be able to estimate. Any question for this first part? So in that case, I'm moving to B part. Is it okay to all of you?
Yes, ma'am.
Okay. So B part. X greater than 0. X is positive. And X assumes very large values relative to Y. This is the context. X is positive and X assumes very large values relative to Y. Okay. So suppose Y is growth rate, okay, and as X, you are considering, Y is unemployment rate, and you are considering the entire national income as X. So it's a huge amount, So X is your national income and Y is your, say, unemployment rate. Okay. So this is the context. Y is very, very low. By the definition, Y is showing a very, very small value compared to X. Now, if both Y and X are in terms of rate, in that case, it will match. However, X you are taking in terms of the absolute number and Y you are taking as a rate, if this is the context, So in that case, there will be, uncomparable gap between the Y and X. The question is X is positive and X assumes a very large value relative to Y. So given this kind of data on Y and X, explain what functional form you will use and how we will estimate the parameters. So this is relatively easy, Anyone?
Ma'am, X equal to e to the power of Y.
X is equal to e to the power of Y. Okay. No, this complication is not required. Anyone else? Any other idea? Somebody else also tried to say something? Any other idea? X is very large compared to Y. So if a value is very large numerically, do you have any idea how we can reduce the value? What transformation or which transformation will reduce the size of the numerical digit?
Log transform.
Yes, very good. Log transformation. Okay. So in this case, we will go for this kind of transformation. So we will keep y as it is and we will take logarithmic transformation of variable x. Okay. So this will be the semi-log transformation. So you are not taking log for the left hand side. You are taking log only for the right hand side variable. Okay, so please write down. Here we will consider the logarithmic transformation. We will consider the logarithmic transformation of x. We will consider the logarithmic transformation of x. Next, the regression equation, or you can write the estimable regression equation, is a semi-log model and we are considering one additive error. Okay, so if one variable is very large compared to the other, in that case, under many circumstances, we take the logarithmic transformation of that variable. However, we have to, when we are discussing all these things, we have to keep one point in our mind. Now, x has a particular economic interpretation. Log of x has another kind of interpretation. In fact, if both y and x are in logarithmic format, in that case, the regression coefficient indicates the elasticity, because in that case, it will be, beta will be d log y by d log x in that format. So it will become the elasticity value. Here that context is not appearing because y we are not transforming in terms of log, y we are keeping as it is. However, we are making a logarithmic transformation of x. So when you will go for higher studies, more advanced courses, you will find that though this is a mechanism, however, if there is a typical research question, definitely we have to check whether logarithmic transformation of one variable will change the meaning of the entire equation in a drastic way or not. If not, then it's a good mechanism. However, if for the typical context, logarithmic transformation is not suitable, in that case, we cannot do it. Okay. So, just blindly we cannot do it. Here, since they are asking a context and telling us to how we will present the model, we can definitely do these things. However, if it is a research question, so always we cannot make logarithmic transformation of any variable. We have to check whether the meaning of or interpretation of this thing remain unchanged, or the entire meaning of the things, entire meaning of the modeling exercise is changing, etc. So all these things are in the background. However, at this stage, we can definitely go for this kind of model building exercise. Next is third one. You are interested in estimating a constant elasticity of demand function. You are interested in estimating a constant elasticity of demand function. So any idea how we will proceed constant elasticity of demand function? You are familiar with this. You did all these things in your micro, especially in case of production. So first tell me what will be the functional form. After that we will discuss about the regression format. Bolo, what will be the function? What is the possible functional form? Ki mone hocche ekটু bolo. You did it in context of micro.
X into y equals to constant.
y is equal to constant, তাহলে কি করে constant elasticity?
আমি rectangular hyperbola হবে।
তাহলে কিরকম ইকুয়েশনটা হবে বলো? y is equal to
Something by x.
by x. অন্যদের
ম্যাম
কিছু
y equal to x by a, y equal to x by a.
y is equal to a, তোমরা a কনস্ট্যান্টটা বলছো, so you can take anything, a x, that will be the thing. Constant elasticity of substitution. Okay, so আমি a বলতে পারি, আমি আলফাও বলতে পারি। Okay? তোমরা যেগুলো করেছো সেগুলো এই রকম, this format. Since ultimately we will move towards the regression format, etc., instead of a I can use alpha, instead of in the standard format, you know, what we use in context of economics, we use alpha as the power of x. So here, if I consider the constant or the technology as alpha, in that case we can present it as alpha x to the power beta. Okay, is it acceptable? Constant elasticity, then you can take log, you know, and beta will be interpreted in terms of elasticity. So if this is the functional form, what will be the elasticity value?
Beta.
হ্যাঁ, আমরা d log y by d log x এইভাবে ভাববো। Okay, so this is the standard format of constant elasticity of demand function. So in this case, what you can do, now we have to move towards the empirical presentation, regression model from this functional form. So this, here we may consider a multiplicative error. This implies y we can present as, we are randomizing it. Okay, so we are doing this. So this is the regression format. This is the regression format. Okay.
ম্যাম
Yes.
বিটাটা ইলাস্টিসিটি আর আলফাটা কি বললেন এখানে?
আলফা তো টেকনোলজি না, প্রোডাকশন যদি ধরো তাহলে টেকনোলজি। এটা কি হয়, ডগলাস প্রোডাকশন ফাংশনের মতো ফাংশনে এটা কি বোঝায়, টেকনোলজি বোঝায় তো।
হ্যাঁ হ্যাঁ হ্যাঁ,
সেখানেও তাই হবে, টেকনোলজি। তুমি যদি এটাকে প্রোডাকশন ফাংশন, টিপিক্যালি প্রোডাকশন ফাংশন হিসেবে তুমি ইন্টারপ্রেট করো। Okay, so these are the things, you know. So Swapnil, are these things clear to you?
Yes, ma'am.
এইগুলো হচ্ছে ওই মডেল স্পেসিফিকেশনের উপর কোয়েশ্চেন, as I mentioned, you know. Sometimes, you know, you will find that some functional form is given to you and you will be asked whether it is linear or not, whether it is linear or not, you know. In our entire analysis, as I mentioned, if a model is linear in parameters, then we will consider it to be linear. Yeah. If it is non-linear in variables, then also it will be treated as linear format as long as it is linear in terms of the parameters of the model. Okay. So remember this thing. If you get a functional format where x square or log x or e to the power x, all these things are used. However, beta, etc., these things are, you know, linear in linear format. In that case, you have to treat the model as a linear model. Okay, so linear model. So I'm giving you some examples. Suppose এক্সপ্রেশনটা এরকম ফাংশনাল, আর একটা I'm giving the functions only. আর এটাকে রিগ্রেশন ফরম্যাট হলে র্যান্ডমাইজ করতে হবে। So suppose these are the functional formats. Are these linear or non-linear? If I consider this for the regression model, should we consider this linear format or will we consider these as non-linear format?
লিনিয়ার এস্টিমেটর থেকে আছে, তো লিনিয়ার কনসিডার করব।
লিনিয়ার কনসিডার করব। বাকিরা মানে ফরম্যাট ওয়াইজ যদি ভাবো, তোমার ওই উপরের এক্সপ্রেশনটা এটা এরকম একটা কার্ভ, তলার এক্সপ্রেশনটা এরকম একটা কার্ভ। এই কার্ভস গুলো আমরা ইকোনমিক্সে রেগুলার ইউজ করছি। ওকে, অল অ্যাভারেজ কস্ট, marginal cost, average, and the reverse of this curve will be average product, marginal product, or S shape. So regularly we are using this kind of shapes. Okay, so all these are linear. So remember these things. As long as your structure is linear in terms of parameters, consider these models as linear model. Okay, consider these models as linear models. I think Madalate কতগুলো functional expressions আছে আমি বলছি। Let me find out. Question number 20 টা দেখবে, হ্যাঁ, chapter 3, chapter 3 যেটা দেখছো তোমরা। Question number 20, given data on y and x, explain how you will estimate the parameters if the following estimate the parameters of the following equations by using ordinary least square method. Specify the assumptions you make about the errors. assumption about the error means কখন তুমি multiplicative error নিচ্ছ, কখন তুমি additive error নিচ্ছ, so all these kind of assumptions. এবার এখানে তুমি যদি দেখো, তোমরা কোয়েশ্চেনটা কি দেখতে পাচ্ছ? কোয়েশ্চেন নাম্বার 20.
Yes, ma'am.
ওখানে দেখো ফার্স্টে এতে দিয়েছি y is equal to alpha x to the power beta. এই একটু আগেই আমরা যেটা স্ট্রাকচারটা করলাম, কনস্ট্যান্ট ইলাস্টিসিটি. Then the second structure is y is equal to alpha e to the power beta x, y is equal to alpha plus beta log x. Then y is equal to x by alpha x minus beta. তারপর ইটা দেখো আমরা যেটা লজিস্টিক ডিস্ট্রিবিউশন করলাম, e to the power alpha plus beta x divided by 1 plus e to the power alpha plus beta x. পরেরটা y is equal to alpha plus beta root x. Next y is equal to alpha plus e to the power beta x. এরকম অনেকগুলো স্ট্রাকচার রয়েছে। ওকে, সো এগুলো দেখবে, if taking the logarithmic transformation it becomes linear, in that case it is linear, and when you are defining this kind of linearity, linearity should come in terms of parameters. As long as your transformed model or the original model is linear in parameters, the model will be considered as a linear one. And if the transformed model or the original model consists of non-linearity in terms of parameters, you have to consider the model as non-linear model. Okay, so this is another type of question, linearity, non-linear, in terms of linearity, non-linearity, etc. Next, as I mentioned, I'll discuss question number 10 and 11. Question number 10 and 11. Any question in terms of linearity, non-linearity, functional form? And I hope all of you will try question number 20. কিছু না, তুমি জাস্ট ট্রান্সফরমেশন করতে থাকো, দেখো সামহাউ তুমি একটা লিনিয়ার স্ট্রাকচার নিতে পারছো কিনা। এবার সেটা লিনিয়ার ইন প্যারামিটারস অর লিনিয়ার ইন ভেরিয়েবলস, এগুলো ভালো করে দেখতে হবে। নন লিনিয়ার, লিনিয়ার ইন ভেরিয়েবলস সবই লিনিয়ার হিসেবে কনসিডার্ড হবে as long as the model is linear in terms of parameters. Next, I am moving to question number 10. So please open question number 10. Two variables y and x are believed to be related by the following stochastic equation. Y is equal to alpha plus beta x plus u, where u is the usual random disturbance with zero mean and constant variance sigma square. To check the relationship, one researcher takes a sample size of 8 and estimate beta with OLS. A second researcher takes a different sample size of 8 and also estimates beta with OLS. The data they used and the results they obtained are as follows. Then you have information on data for both researcher 1 and 2. Researcher 1, y variables are 4, 4.5, 3.5, 4.5, 5.55, etc. And observations on x are either 3 or 4. Researcher 2, you have information on y. However, the information on x is again typical. The values are either 1 or 10. So in case of researcher 1, x values are either 3 or 4. And in case of researcher 2, x values are either 1 or 10. And then they are giving the estimated regression model. Y hat is equal to 1.875 plus 0.750x. In parenthesis, we are getting the standard errors of the regression coefficient. Okay, R square value is there, sigma square value, sigma hat, that is SU, that is also there, 0.48. For the second researcher, we are getting the similar kind of information. R square, sigma hat, y hat, etc. Can you explain why the standard error of beta hat for the first researcher is larger than the standard error of beta hat for the second researcher? Okay, so standard error of beta hat for the first researcher is 0.339, whereas the standard error of beta hat for the second researcher is 0.038. The question is, why first researcher is getting greater standard error compared to researcher 2? Whether there is any explanation. Yes.
What is researchers to standard error for beta hat? Could you repeat?
0.038. একটু লিখে দিচ্ছি। Researcher 1, researcher 2. This is 0.339. This is 0.038. These are the values. Question is whether you can interpret this finding or not. Any idea, anyone? Any guess? So would you please write down the formula for variance of beta hat? What is the formula? Simply variance of beta hat formula.
Sigma u squared by summation over 1 I runs from 1 to n xi minus x bar squared divided by that in the denominator.
Yes. You already did use used it today while you are doing the numerical exercise. So everybody, you know the formula sigma squared divided by summation xi minus x bar whole square. That is the definition of variance of beta hat. Now, given this definition of beta hat and given the data set, do you have now any idea why one variance is greater and the other one is smaller?
Ma'am, I had a question. Ma'am, were the number of sample observations different in both cases?
No, they are same.
Okay.
তোমার কাছে কোয়েশ্চেনটা নেই, দেখতে পাচ্ছ না? না, একসাথে অসুবিধা হচ্ছে।
ম্যাম একসাথে দুটো স্ক্রিন অ্যাক্সেস করতে একটু অসুবিধা হচ্ছে।
সাইজ হচ্ছে 8 হ্যাঁ, দুটোতেই 8। স্যাম্পল সাইজ ইজ সেম। ওকে, আমি আরেকবার রিপিট করছি। ফর রিসার্চার 1, y observations are 4, 4.5, 4.5, 3.5, 4.5, 4.5, 5.5, 5, 1। আর তোমার x ভ্যালুস গুলো হচ্ছে, সরি লাস্ট ওয়ান ইজ 5। x ভ্যালুস গুলো হচ্ছে প্রথম চারটে 3, পরের চারটে 4, 3, 3, 3, 3, 4, 4, 4, 4. This is x values. 3, 3, 3, 3, 4, 4, 4, 4. A researcher 2, y values are 2, 2.5, 2.5, 1.5, 11.5, 10.5, 10.5, 11. X values are 1, 1, 1, 1, and then 10, 10, 10, 10. Now, any guess? why this standard error of beta hat is greater than this standard error of beta hat?
Miss?
Yes, Shivani, yes.
In the denominator for standard error of beta hat, we use xi minus x bar whole square, the summation of that.
Yeah.
And for researcher 2, the difference between xi and x bar is very large as compared to that for researcher 1.
Yes.
Because here we have 10 and 1 and there we have only 3 and 4. The difference is very large in the denominator.
Very good, very good. This
And
is
as the denominator is very large, the value gets small.
yeah, yeah, that is the answer. Very good. So, if I write the formula for variance of beta hat, okay, so we can say that variance of beta hat varies inversely with variance of xi. Okay, can we say this thing? Sigma squared is a constant which is in the numerator. So given that value, can we say that variance of beta hat varies inversely with variance of xi?
Yes, ma'am.
But in case of researcher 1, variance of xi is smaller compared to that of researcher 2. Because researcher 1 এর xi গুলো এরকম। আর researcher 2 এর গুলো এরকম। Okay, so summation xi minus x bar whole square, this part, variability of xi, that is higher for researcher 2 compared to researcher 1, and therefore, this variance or the standard error will be lower compared to this. Okay, this is higher. So this is the idea, variance of beta hat is an inverse function of variance of xi. So if we get the information of the database where variance of xi is larger, in that case, we will have variance of beta hat in this format. Now, if you look at question number 11 is very similar to this one. Let me check question number 11. Question number 11 is, since the variance of regression coefficient beta hat varies inversely with the variance of x, it is often suggested that we should drop all observations in the middle range of x, and use only the extreme observations on x in the calculation of beta hat. Is this a desirable procedure? So I'm repeating. Since the variance of regression coefficient, I think those who will be not able to check two screens simultaneously, it will be best if you write the statement. Okay, because there are many things here, so it will be best if you write the thing. Since the variance of regression coefficient beta hat, since the variance of the regression coefficient beta hat varies inversely with the variance of x, it is often suggested that we should drop all the observations in the middle range of X. We should drop all the observations in the middle range of X and use only the extreme observations on X. And use only the extreme observation on X in calculation of beta hat. Is this a desirable procedure? Is this a desirable procedure? So what they are trying to tell us, variance of beta hat is an inverse function of summation xi minus x bar whole square. So, you know, we will drop all the observations in the middle range. Okay. So the gap between xi and x bar, that will increase. If we only consider the values which are at the top position and which are at the bottom position, in that case the gap between the mean and the observation, that will increase. So drop all the observations in the middle position, take only the observations which are at extreme positions, and then you calculate summation xi minus x bar whole square. In this case, variance of beta hat will be lesser compared to the case if you keep the observations in the middle range. Now, in this entire ethics of regression, we have in our mind, we have to minimize the variance of beta hat. Lesser the variance of the regression coefficient, better the position. Therefore, all these issues are coming. Somehow we are trying to reduce the variability of xi and thereby reducing the variance of beta hat. Now the question is whether this is a desirable method or not. You know, we are understanding lesser the value of the variance of beta hat, better the position, because we have to find out the best linear unbiased estimator. Now to have this thing, if a particular researcher drop all the observations in the middle range of xi to increase the variation summation xi minus x bar whole square, you know, will it be a desirable procedure? The question is like this. So first tell me whether you are getting the question. Dighi, Lakshadip, are you getting the question?
Yes, ma'am.
Dighi, what about you? Getting the question? Barsha?
Yes, ma'am.
Getting the question?
Yes, ma'am.
Okay. So, what do you think? Is it a desirable process?
Miss?
Yes. Yes, Shivani. Yes.
Miss, our goal is to reduce the variance of beta hat. And the variance of beta hat is inversely proportional to variance of x. So if we take the extreme values, then the variance of x increases, which thus reduces the variance of beta hat. So it is desirable.
Shivani, are you not losing a number of information in this process? You know, so when we are talking about empirical investigation, you should be very clear about your broader goal. if we can maintain everything properly, the representativeness of the database, everything, and then there is a method by which we will be able to reduce the variance of beta hat, then it is acceptable. However, you have to check both the plus and the minus side of a particular statement or particular state. Okay, so we will not judge a statement looking at a narrower base. You have to look at the statement from the broader context, whether you are losing information, whether you are bringing subjectivity. All these issues are there, isn't it, Shivani?
Yes, miss.
So, so when we are thinking about an answer, we have to check both the sides. And then if we find that the positive thing will be greater compared to the negative aspects, we will definitely go for that. Otherwise, if we find that the negative aspects are more compared to the positive aspect, we have to control ourselves. So, I'm telling you the structure of the answer to this question. First of all, so let me use the So this we can also write as, typically if I want to follow the definition of the variance, is it okay? If I properly like to write the variance of xi, is it okay to all of you?
Yes, ma'am.
First you write down this. Next, please take a note. If we delete central observations and consider only the extreme values of x, if we delete central observations and consider only the extreme values of x, variance of xi will increase. Variance of xi will increase. But simultaneously, n will fall. N, number of observations, n will fall. So in the denominator, therefore, if you look at the board, one part is increasing, another part is falling. A mutual cancellation may be possible. A mutual cancellation may be possible. Thus, considering only the extreme values of x, variance of xi rises, but it may not serve our purpose of reducing variance of beta hat OLS.
ম্যাম serve our purpose of তারপর কি বললেন?
Purpose of minimizing variance of beta hat OLS, V of beta hat OLS. যেটা আগে বলেছি, there may be mutual cancellation between decrease in n and increase in x. So ultimately, variance of beta hat may remain unaffected. So that is the thing. Second point. If we drop several central observations, we will lose some information. We will lose some information. Third point. Beta hat OLS is derived on the basis of an objectively drawn sample where all samples are equally likely. In this case, we can't arbitrarily fix. Some observations as extreme and others as central observations.
ম্যাম এই জায়গাটা একবার বলুন তো, arbitrarily fix.
In this case, we can't arbitrarily fix. Some observations as extreme and others as central observations. Some observations are extreme and others as central observations. If this is done, the sample will no longer remain objective, it becomes subjective. If this is done, the sample will no longer remain objective, it becomes subjective. And hence loses representativeness. and hence loses representativeness. Okay, so these are the things you need to check, you know. All these are related to the things already done, you know. However, you need to understand how we will put the matters when a context appears. Question number 12 from Madala, that is also important. Suppose you are attempting to build up a model that explains aggregate savings behavior as a function of level of interest rates, savings as a function of interest rates. Would you rather sample during a period of fluctuating interest rates or a period of stable interest rate? So you need to build up a model where saving is a function of interest rate. So what kind of period you will select for modeling your exercises, or from which period you will collect your observations, when rate of interest is quite stable or when the rate of interest is fluctuating. Okay, so this is the question. So can you tell me what will be the answer briefly? What will be the answer? So stable values of X variable is better, or fluctuating values of X variable is better?
Ma'am, stable.
Stable? Rest of the student?
Unstable.
Fluctuating values. Otherwise, you will lose the variability of the observations, you know. Dighi, Shopnil, you know, rest of the students, you know. When you will go for empirical model building exercise, you need variation. Variation, you know. So in your savings rate of interest model, rate of interest is the X variable. So if you control its variability, its variance will be reduced. Summation xi minus x bar whole square, that will be reduced, because in a stable period, you know, interest rate will move only around the mean value. Okay, so summation xi minus x bar whole square, that will be very, very small. That is not desirable. Okay, it is desirable that you will collect the information when the interest rate is fluctuating. Okay, and then only you will be able to get, you know, the proper empirical estimation of the savings equation. Okay, so all these things are there. Please check the questions. You know, you did, I told you to solve up to, you know, 7, etc. Now you check question number 8, 10, 11, 12, all these things are there, you know, and these are very close to economic model building exercises. And then there is question number 20, which is telling us different functional forms, and on the basis of different functional